Welcome to another session with Ms. Taylor. This time we're looking at empirical molecular formulas. In this problem, you are given percentages of the elements within the compound. Now, whenever you're given percentages, all you have to do is change that percent sign to a gram. Why can you do that? If you assume there's 100 grams of compound, then each percentage becomes however many grams of each element you have. So first, let's list the grams of each compound that we have. So we have 26.58 grams of potassium, 35.35 grams of chromium, and then 38.07 grams of oxygen. Now, the whole technique of doing this type of problem is trying to get you actually to a mole ratio. So the first thing you're going to do is convert from grams to moles. Okay, so potassium is 39.0983 grams per 1 mole. Chromium, a little bit heavier, is 51.9961 grams per mole. And then good old oxygen is 16 grams per 1 mole. Okay, so doing this, and I always carry this out at least 4 decimal places. We've got 0.6798 moles of potassium. We've got 0.6795 moles of chromium. And we have 2.3794 moles of oxygen. Now, these aren't nice pretty numbers, nor is this a mole ratio. To get the mole ratio, you should look at your numbers and divide all of them by the smallest. So in this case, our smallest one is going to be our chromium. So we're going to divide everything by 0.6795. Okay, so we should get a number close enough to 1 that we can safely say 1 for both of these. Now this one becomes a problem. You actually get 3.502. Now, you cannot round that up to 4. Okay, you cannot. So if you have a number at this step that one of them is not safely rounded up or down, it's safe to round up if it's 0.1 or 0.2, or excuse me, to round down if it's 0.1 or 0.2, or round up if it's 0.8 or 0.9. But this is 3.5. So we need to multiply all of these numbers by the same number so that we get a whole number ratio. And 2 will work in this case. Sometimes you have to just trial and error until you get whole numbers. But this one, you're going to get 7. So your empirical formula is going to be K2Cr2O7. Now, we also wanted the molecular formula. To get the molecular formula, we need the molar mass of this divided by the actual molar mass that was given to us in the problem. And what we are going to see, actually, I said that backwards. You're supposed to do the actual divided by the empirical, but it's the same. So the molecular formula is K2Cr2O7. Thanks for watching.